Good afternoon, viewers. On my personal behalf and on behalf of Indira Gandhi National Open University, I welcome you all in this session of teleconferencing coming to you live through Educational Satellite EduSat. The topic for today's presentation I have chosen particularly the decision support system for infrastructure planning. In this topic, you must be seeing that we have to develop a particular decision support system for a particular infrastructure planning. Infrastructure planning deals with many ways, but here in this case we will be dealing with a particular problem where we will be solving a ambiguous where a decision is to be made and you are given a list of attributes and some list of alternatives available to you when you have to join two cities in our country where alignments are to be designed and which alignment is best suited under the list of the attributes which are available to you or which you work out with the brainstorming session that we will be seeing. So here the decision support system we will be developing with the help of a proven management tool which is called multiple criteria decision making. So on the basis of multiple criteria decision making, we shall be deriving this model which will help you in identifying the most optimal or the best alternative among the available alternatives in light of the list of attributes which have been generated through the brainstorming. So before going into the details of this topic, let's see that how it is relevant for the students of our university. There are three programs from School of Engineering Technology. One is BTCM, BTWRE, BTech Construction Management and Water Resources Engineering. They have got one course named Principles of Engineering Management and Economics, ET 524A/ET 534A. For them this topic is quite relevant. For BTME students who are BTech Mechanical Engineering student, for them it is under the course Industrial Engineering and Operation Research, BME 035. It is quite relevant. And lastly, for the Diploma in Electrical and Mechanical Engineering exclusively launched for Indian Army, for those students who are located at Bangalore, this program is again helpful for them under their course BME 044 Industrial Management. So this is the basically list of the programs for which this topic may not be of directly available to you in your course material, but at the same time if you see this topic has the relevance in decision theories. You might have covered some decision theories in your syllabus, but this particular theory, the multiple criteria decision making or multiple criteria decision theory, this particularly deals what I explained before giving you the relevance of this program, but I'll also explain it with the help of a small example. But before that, let us see that how I shall be covering this presentation. Little bit of introduction in the beginning, then decision scenario in the industry, how decisions are being taken and how the decisions are being affected by various factors, that we'll be seeing. Multiple criteria decision making, popularly known as MCDM, basically analytical hierarchy process, AHP, which is nothing but a technique of MCDM. We'll also see by applying this technique how can we get a answer or to a solution to the problem given. And then consistency check in AHP. This is basically very important characteristic of this method, where a consistency check available where the decision makers are making their decisions, and the beauty of situation is that this method tells that how consistent are the decision makers when they are taking decisions, when they are told to take some decision. So this is very good feature of this technique, and finally we will go for the conclusions of this. Before going into the details, let me tell you what multiple criteria decision making is for a layman. Suppose you have to subscribe a newspaper for your house or for your office. There are so many alternatives are available. There may be national newspapers, Hindustan Times, Times of India, Pioneer, Asian Age. There are so many available newspapers with you. You have got certain criteria in your mind that these criteria I should follow for selecting a newspaper, where criteria may be the cost, the first. If it is only the cost, the criteria, then it is not a multiple criteria decision making problem. It's a single criteria decision making problem, where you will directly go for the cheapest newspaper. If some newspaper is available in 1 rupee 25 paisa and others are at 3 rupees or 2.5 something, then you will directly go for 1.25 rupee, because that is the alternative available to you as per your single criteria of cost. But suppose you want to select a newspaper where not only cost, there are some other factors like coverage of politics, coverage of sports, coverage of social issues. All these becomes the criteria for you. Then that newspaper should have adequate coverage of politics in the country and international. It should have the sports column also very good. In that case, the decision will be difficult. Had it been only the cost, then the decision is very easy. You can go for the cheapest one. But when the decision is to be made that you have to select a newspaper where various factors are affecting, then decision becomes complex and it requires some decision tool to take this decision. So this is basically the multiple criteria decision making, and on which we will be harping upon for a infrastructure planning, in which you have to select a best highway route, best alignment of the highway between the two cities. We can see on the screen, in our country, you all know, you are associated with engineering, in diploma also you have worked, you are working. You know that in our country, the huge amount of money is being pumped in the infrastructure projects through various 5-year plans, and these huge investments are made in these projects, infrastructure projects. The ever spiraling construction cost and increasing tightening of money have fostered the need of sound decision making system by which you can take right decision at right time. Decision support system should be able to handle not only the quantifiable factors, it should also address the non-quantifiable, or you can say intangible factors. So this is basically the situation which prompts us to take some decision support system, to develop some sound decision support system which can help us when we want to take some decision. So this is the introduction. We can see here is one organization. This organization is working and there are many factors around it. You can see first is the technological factor, the economical factors, the social factors, ethical factors, and political and legal factors. So these are different factors which are affecting the organization when you are taking decision. Suppose an organization wants to take one decision, then one decision taken may be in support of one factor, but it will be in contrary of the other factor. If you are going for a good house, then its specification may be higher, but you have to spend more cost. So they are conflicting. Your criteria of getting a modular kitchen may conflict with the criteria of your cost. Your pocket may not permit that. So in that situation where the criteria are conflicting, that one criteria is not supporting the other criteria, the problem becomes more complex. And here in this graphic, it has been tried to show you that an organization is working under so many factors which are influencing the working of the organization, and those factors are also conflicting in nature. Let's see another graphic here on the screen. It is a conceptual model of modern decision making, how the decisions are being made in the organizations. If you see, there are objectives. There are several objectives of any organization: the social objective, economic objective, and technical objective. And with the objectives, options are always available. If that is the objective, this is the option available. So we can again say that the social options, economic options, and technical option put together, if you all the three if you put, then finally you get the option social, economical, and technical options. Now after this, one is your objective, other is the options available. Now another very important thing comes into the picture, which is basically the cost and resources constraint. Every organization faces the constraint of resources. The resources may be in terms of anything. You all know there are 4M in any organization, and particularly for a construction industry: man, machine, money, material. So in this, when we experience the crunch somewhere, the cost and resources crunch, then you have to take decision under those available options, and you take a decision which is a socio-economic technical compromise solution. Here you compromise at one point or the other point, and finally the decision which you take under the influence of the constraints available or the constraints imposed in terms of resources and money, and you go for a compromise solution. Now this also calls for a sound decision making tool required for this kind of situation, where you can deal with the problem where you have to take decision under the constraints. Now let's see what is multiple criteria decision making. You see on your screen, the decision maker is at the top. The objective is to finalize a most effective or the most optimal alternative in light of a list of criteria. Here you see A, B, C are nothing but the attributes available, symbolically taken here, have been taken here for this graphic, the three alternatives criteria, three attributes which are nothing but the criteria, and there are two alternatives available for the decision maker to choose from under the influence of A, B, C. Now this is basically a multiple criteria decision making problem. We can define the MCDM problem as a problem if and only if there appears at least two conflicting criteria and there are at least two alternative solutions available. As I told you just now, that for going for a house, if you are selecting a house for yourself, you may be asking or you may be desiring to have a marble flooring, or even you can go for some good modular kitchen, but at the same time your budget is limited, your resources are having the constraint, and in that time nothing but a compromise solution is to be taken. So this multiple criteria decision making definitely helps you in taking decisions which are always you confront with in one way or the other way in daily life and in your professional life, where you have to take decision under the influence of the criteria considered. If we see on the screen, there are some situations which arise in the industry. First one is the bid evaluation. Suppose you have asked for the bids from the contractor and those bids are to be evaluated, then this is also a case of multiple criteria decision making. Capital busting for hospital management, this has been taken as the live case examples where the researchers have published their papers. Design build proposal selections, several proposals are available with you and you have to select the best one from that. The location selection for a small scale hydro plant, this is again from one researcher. Project selection, selection of food control projects, river basin planning, water resources planning and succession planning. These are some situations in the industry where the multiple criteria decision making can be applied and which is of directly of interest of the industry. So these are some examples in the industry. If we see on the screen, there are several techniques available for dealing with the situation under MCDM. Weights and score method, multi-criterion Q analysis 2, there was one also, goal programming, graphical method, cooperative game theory, utility function model, fuzzy set methodology and analytical hierarchy process. In this presentation, we will be dealing with only AHP, which is one of the best suited technique for this kind of situation where we have to take decision under multiple criteria decisions. So this in this presentation we will be seeing the details of analytical hierarchy process, and other methods are also available which can be used, but you know that a particular method is good at the particular situation. Here particularly in industry and more particularly in infrastructure projects, the decisions which we have to take are basically best suited by the AHP technique, and so for that we will be describing the AHP technique, particularly the BTME students, those who have direct interest of this technique and MCDM in their course on industrial management. They can see it carefully that AHP technique which is used for making decisions under multiple criteria, how we apply this technique. we know that AHP, when we apply for decision support system, there are some steps which are to be followed. You can see on your screen. First thing we do, decompose the decision problem. Thereafter we establish the priorities. Then we synthesize the priorities, and finally we determine the overall priorities of various alternatives. These are the four steps through which this AHP technique is applied. First is the decomposing of decision problem. Here, in decomposing the decision problem, AHP, as you know by name, it is analytical hierarchy process. In this analytical hierarchy process, in the first graphic where I showed you A, B, C as the criteria and 1 and 2 are the alternative, this is nothing but a hierarchy, where at the top point there is the goal, the objective of the problem, where we have to select the we have to make a decision. So that is basically from context, what context we are applying the problem, basically that determines the objective. Here in our case, the case study which I have taken, that infrastructure planning, there are two cities. Between these two cities, a road is to be laid down. How to lay down the road, what alternatives available. So basically the objective is to select the best highway project. So that is the first thing on the top, which is the goal of whole problem. And thereafter, and the second hierarchy, there is alternatives available, there is attributes available, the criteria under which we have to take decisions. So the criteria come on the second position in the hierarchy, and finally the third position is the alternatives which are available to you for making the selections. So this way the whole problem is decomposed in a hierarchy, where the top is the objective or goal, the second is basically the attributes, and third is the alternative. We, after decomposing the problem in hierarchical form, we make some calculations. I will be describing how to make this calculation. Basically, we at every level we compare the components available at that level. Suppose for our problem which we saw in the beginning, that after the top there are three A, B and C, there are three attributes. Now these three attributes are to be compared by themselves. As you all know that if you are being told in a heap of stone that you have to select the heaviest stone from this heap of stone, then it is not an easy problem. You can't identify the heaviest stone from the heap of the stone. What you will do, you will take two stones together in one hand and the other hand, and then you have to see which one is heavier. Then you take the next one, and on the other hand, which you just throw the lighter one, you take the other one. If it is still lighter than the other hand stone, then you again throw it, because it is the lighter than the already you are holding the other stone on the other hand. Then till you get the heavier stone than the already there in your hand, you have to continue with this exercise, and finally this way you can find out which is the heaviest stone, because every time you have to throw the lighter stone and you have to keep the hold of the heavier stone, and any time when you get a more heavier or heavier stone, at that time you have to throw that stone which you are holding at this moment as the heavier by that time. So this way, up to that end, you will examine all the stones in the heap and you come up with a solution that this is the heaviest stone in the heap. But for that, what did you do? You basically compared two stones at a time, and wherever you get the heavier you retained, and wherever the lighter was there you threw it. So this way the paired comparison, two components, two elements are to be paired at once, and then only you have to find out that which one is more important. In your case it was heavier, otherwise I will say it is more important. Now the question is that in the case of that stone selection, you had to only say that which one is heavier. But here another dimension is added, that which one is heavier and by what degree. So in a paired comparison, we compare two elements A and B, and there you have to make a judgment that A is more important to B. But another question which is after that asked, that how much important, on a scale of 1 to 9, you have to judge that A is more important to B by the degree of 9. If it is strongly important, suppose two things are being asked to you which are so you can say that distinct, that one is most important and one is very less important, then you have to give that the ranking 9. Otherwise, if they are equal, then you have to give 1. And other your judgments will lie between 1 to 9. We'll see how we do. So this way we establish priorities. Then after establishing priorities, we synthesize the priorities, we club them, and we find out the overall priorities of various alternatives. Here, the first thing on a screen, you can see the decompose the decision problem. Here the overall goal is the first thing which is on the top. As I told, the goal is on the top. A, B, C, D and E are nothing but the attributes, criteria. These criteria basically will determine the selection of alternative X, Y and Z. Now you can see on your screen, this basically is a hierarchy. In this hierarchy, A, B, C, D, E are nothing but the criteria which you have generated, which you have identified for this problem. X, Y, Z are nothing but the 3 alternatives available to you. You can again go back to the example which I gave in the beginning of your newspaper selection. X, Y and Z are nothing but the newspapers options available like Hindustan Times, Times of India and Pioneer. A, B, C, D, E are nothing but the coverage of politics, coverage of sports, international arena, some other factors which you think of considering while selecting the newspaper. Cost will definitely one of the criteria. So these A, B, C, D, E are those criteria. Overall goal is to select newspaper, and X, Y, Z are the options available in terms of the newspaper to you. On your screen you will see index in LP is equal to local priority and GP is the global priority. Basically these two new terms being introduced as this label. Local priorities are basically when you compare A, B, C, D, E together paired wise, A to B, then A to C, A to D and A to E, and then B to C, B to D. This way when in pairs you compare, we'll see how we compare. At that time, whatever value you get is the local priority of that stage of the hierarchy, and when it is multiplied with the local priority of global priority of the parent node, on that node on which it is attached, then you get the global priority of the second stage. And that way when you go further on the third stage or the third level of the hierarchy, where you again calculate the local priorities, and when you multiply this local priority with the global priority of the parent node, then you get the global priority of X, Y, Z, which is nothing but the ranking of the alternative, and accordingly you can choose the alternative, you can select the alternative. We go further and we formulate the problem. As I told again and again, the problem here with the case study I have taken is a project of highway construction was sanctioned by the authorities to allow alternative routes between 2 important cities, thereby contributing to the economic growth of the area. So this is the problem, that between the 2 cities, we have to connect these 2 cities by a highway. Now options are available that we can do in a first stage this much work, in the second stage we can do some other work. We have to take this much width highway, we have to use this material of highway. This way options are available, and then we have to first finalize the criteria. Under what criteria we are going to select the highway. On your screen you can see the list of attributes. For this case study I have taken 7 attributes: the capital cost, internal rate of return, mobility, safety, reliability and comfort, maintainability, travel impedance and environmental impact. These are the 7 attributes which has been taken here straightway, but it is not again simple to generate the criteria. For this, normally a decision team is being constituted, and that decision team sits coolly, and they thereafter brainstorm and they come up with the list of attributes or the list of criteria which should be considered for the selection of the highway project. So for this case study, these are the 7 criteria which have been considered for the alternative routes. I'll show you the alternative routes here, which are basically 5 in number. 5 alternatives are available to you. On your screen, when you saw the attribute list, the capital cost and internal rate of return, these are basically the quantifiable parameter, whereas the remaining 5, which are mobility, safety, reliability, travel impedance, environmental impact, these are all intangible parameters. You cannot quantify these. These cannot be in any unit. You cannot put in any unit that maintainability is 10 units or maintainability of this particular alternative is 5 units. No, you can't do. It's an intangible. We call it the non-quantifiable components or non-quantifiable elements or linguistic parameters. Here, good, bad, outstanding, these are some linguistic parameters. You have to rate the things according to these parameters, and somehow some method should be available to you so that you can assign the numerical values to this linguistic parameter, by which when you add, you can go for particular value score or the score of particular alternative, and this way you calculate the scores of all the alternatives, and one which makes the highest score is qualify for the selection for that particular alternative. But here we go for the alternative. This is basically the list of the attributes we have considered after brainstorming of the decision team. They have come up with these 7 attributes. Now we see the alternatives. On your screen there are 2 alternatives of this highway we have shown here. The construction of first alternative, the construction of single lane gravel road and 4-meter wide bridge in first stage, followed by road widening of 2-lane, surface upgrading to macadam, and addition of 1 more 4-meter wide bridge in second stage. Likewise, the alternatively what we can do, the construction of single lane gravel road and 4.75 meter wide bridge in the first stage, same as the first one, followed by widening of the road to 2-lane surface upgrading to macadam and widening of bridge to 7.6 meter, whereas in the first alternative it was 4 meter, it is 7.6 meter width in second stage. So there are 2 stages basically envisaged for these 2 alternatives. Let's see the alternative 3rd, 4th and 5th. Third alternative says that the construction of single lane macadam road and 4-meter wide bridge in first stage, followed by widening the road to 2-lane macadam and addition of 1 more 4-meter wide bridge in second stage. The alternative 4 which is available to you is the construction of single lane macadam road and 4.75 meter wide bridge in the first stage, followed by widening of road to 2-lane macadam and bridge to 7.6 meter width in second stage. And last alternative is the full scale construction of 2-lane macadam road and 2-lane bridge in a single stroke. It is the no stage, second stage, only in a 1 stage you can go for whole construction. So this way these 5 alternatives are available, 7 attributes are available to you. Now we see how to develop a model for aggregating these 2. Now first thing is decompose the problem into hierarchy. As I showed you, A, B, C, D, E and X, Y, Z, here the things have been taken place where the attributes have been put here, the capital cost, internal rate of return, mobility, safety, reliability, comfort, maintainability, travel impedance, environmental impact as the level 2, the attributes at the level 3, alternative 1 to 5, alternative 1, 2, 3, 4 and 5 at the lowermost hierarchy in this decomposed shape of the problem. So this is the first step which we have done, that we have to decompose the problem in a hierarchical form. So this has been done, and the top select the best highway project is nothing but the objective of our problem. Now we have to establish the priorities. Now for establishing the priorities, broadly we do the things in 3 steps. First is the construction of a square decision matrix, then analysis of consistency in decision making, which I told this is a special feature attached to this technique where you can even find out the consistency of the decision maker. Suppose B is twice important to A and C is thrice important to B, then in that case C should be 6 times important than A. It is the perfect consistency in decision if someone takes this kind of decision. But normally in our day-to-day decision making we are not consistent, and suppose we are saying B to twice important than A and we are saying C as the 3 times important than B, but we may say that C is 5 times important than A. In that case while we are taking decision between A to B, we had something. When we took decision between B to C, we had something. But on the basis of these two decisions, the third decision when we are being told to compare A and C, we are not consistent, because we are saying the 5 times, whereas the mathematics shows that it should be 6 times. If you say it at the 6th time, then definitely it is the perfect consistency. But normally, whenever we take decision, we are not so consistent in our decision making. So that's why in this method of analytic hierarchy process, the consistency check is a beautiful feature attached to this technique, where you can measure the consistency of the decision makers. Some percentage of inconsistency is allowed in the method. We have a method by which we can find out the consistency in terms of the consistency ratio of the decision maker. That comes in terms of percentage, and up to 15% inconsistency in the decision of the decision makers is permitted, and beyond 15%, if consistency ratio is coming, how we calculate consistency ratio will come just now, but if consistency ratio is more than 15%, definitely we should request back to the judgment maker or the decision maker to revise his judgment. On your screen, you are seeing the 3 basically the stages on which we establish the priorities. First is the construction of a square decision matrix. Second is the analysis of consistency in decision making. Third is the computation of priority vector. Again, on the screen you see that lambda max, which we ultimately calculate from the square decision matrix which we make, it is nothing but the greatest non-zero eigenvalue, and priority vector is corresponding eigenvector. Students, you all may be aware, and you all may be thinking what this eigenvalue and eigenvector is. Let me take you to your mathematics course, where you might have studied rank, order of matrix, and you also know that for a square decision matrix you can always calculate the eigenvalue and eigenvector. So here the problem is reduced to a mathematical problem, that a decision matrix which you frame on the basis of the paired comparison, that I will show how we will be doing that when we compare A to B, A to C, A to D and A to E, and we assign some values which I told from 1 to 9, you construct a square decision matrix. Your problem just reduced to the calculation of eigenvalue and eigenvector of that square decision matrix, and you all know that we can calculate eigenvalue and eigenvector only of a square decision matrix. Here in this case the decision matrix take the shape of a square decision matrix, square matrix, so we take the advantage of calculating eigenvalue and eigenvector. Here the greatest non-zero, mostly the eigenvector values may be 0, but greatest non-zero eigenvalue is nothing but the lambda max we have said, and that we have to calculate. But don't get frightened by calculating. When I say that you have to calculate eigenvalue and eigenvector, you are not going to deal with anything with the mathematics here. Some approximate methods are available by which we can calculate these eigenvalue and eigenvector, which works well for our purpose, for purpose of basically ranking of alternative. These are very good, they are good approximate methods. We will see how we calculate, and straightway we go to consistency check. Consistency check, the lambda max which I told you is the non-zero eigenvalue minus n. N is nothing but the order of the matrix. If matrix is 3 by 3 or 7 by 7, then 7 or 3 is the n. If you see the consistency index, you have to find out lambda max minus n divided by n minus 1. N is nothing but the order of the matrix. After finding out the consistency index, you have to find out the consistency ratio. Consistency ratio is nothing but the consistency index divided by random index. This random index has already been generated for different order matrices. Suppose you are taking decision for 7 order matrix, then random index is already available, and that value if you put, then this multiplied by 100 gives you a percentage, and for good results the consistency ratio should not be more than 15%, as I told in the beginning. Now we will see how we calculate the consistency ratio also, lambda max and priority vector. Square decision matrix for attribute evaluation, you all remember there are 7 attributes available to you. At the second level, the CC, IR are nothing but the abbreviated forms of those attributes. Here you have to compare each element on the top with the element on the left. For example, CC is compared, CC on the left is compared with CC on the left is compared with the CC on the top. Here this CC is when compared with the CC on the top, they are equal, so 1 is entered in corresponding cell. The same way, when this CC is compared with IRR, you have to make a decision that which is more important. If CC appears to be more important, then you have to enter a value from 1 to 9, that how important it is. Here in this case, it has been told that CC is more important. If CC on left is more important, then you have to put integer value here, and if it is the top one is more important, then you have to put the reciprocal of that. I'll show you. Here CC is more important than IRR with the weightage value of 3. So you put here 3. CC when compared to mobility, it is coming to equal, so you enter 1. CC when compared to safety, reliability and comfort, it is again taken as same, so it is coming to 1. With the mobility, maintainability, it is coming 3. Likewise 3, environmental impact, again it is coming 3. So means here the CC is outweighing every element on the top. That's why all integer values have been entered on the first row. In the second row, if you see, when IRR is compared to CC, which you have already compared in the last calculation, it was 3 with CC more important than IRR. Then on the transpose position in the matrix, you have to enter the reciprocal of that. For example, here CC was more important than IRR by degree 3. When you compared reverse, the IRR with CC, it should be reciprocal of that, that is nothing but 1 by 3. So this way, this value of 1 by 3 here is basically entered automatically when you enter this 3. All these values on the row 1, basically when you go to column 1 are nothing but these are the reciprocal values at the transpose position. Likewise here, whatever value we find out, these are coming as the reciprocal values on the transpose position of this. So for taking decision, for making decisions, you have to only, when this diagonal you see all are 1, because when you compare the element with itself, it comes the value 1, which is equal. So all diagonal from top to bottom diagonal, from left to right diagonal, this is coming 1, because when you are comparing the element with itself. So it is coming 1. On the top, this triangle you have to make decisions, you have to assign the values, and these values are basically on the lower triangle automatically gets entered at the transpose position in form of the reciprocal what you entered in the upper triangle. So this is also very good, that you have to take lesser number of decisions, you have to take only decision on the upper triangle, and lower triangle values get filled automatically as the inverse of what you put on the top. So after completing this way, when you complete the whole this matrix, now the problem is that you have to find out the eigenvalue and eigenvector of this particular matrix, which is the square matrix. It's a 7 by 7 matrix. Now you have to find out the eigenvalue, and after getting all the eigenvalue, you have to find out the greatest non-zero eigenvalue, and for corresponding that greatest non-zero eigenvalue, you have to find out the eigenvector. This eigenvector, when normalized to 1, basically gives you the priority vector of those particular elements which you have compared. We can go back to slide again, and here I will try to show you that eigenvector. Basically, when we have to calculate the non-zero greatest eigenvector. For that, the methods are available in mathematics, but for the higher order matrix, it is quite cumbersome and time taking. In that case, what we do, we multiply this 1 with the value of 0.22. The question arises from where this 0.22 comes. Okay, this 0.22 is nothing but the eigenvector. This eigenvector we have obtained by multiplying all the elements in the row, all these 1 into 3 into 1 into 1 into 3 into 3 into 3. This you do, and thereafter you take nth root. Here the n is 7, so you take 7th root of that and you enter value. Likewise, you multiply all the rows and take the 7th root of all the values which is coming, add all those, some value will come at the bottom, then you normalize it to 1. You get when this much from the sum which is coming, suppose it is coming x, and you are getting the value a, b, c, d, e, then a upon x, b upon x, c upon x. This way you can normalize the values to 1. Their sum should be 1. This is nothing but PV which is coming on the last column is the normalized value. The sum of all this is 1. So first you calculate this by multiplying all the row element and then taking the nth root. And after this you have to multiply, you have to add all the columns. When you add all the columns, some values will come at the bottom. When you multiply this value which is coming here, suppose the sum of this first column by the sum of by the priority vector, normalized priority vector, and then second column by the second priority vector, by the third column third, this will give you the lambda max. This is the approximate method of calculating the non-zero eigenvalue for a decision matrix. So this way we can finalize the lambda max. And remember that consistency index was nothing but lambda max minus n upon n minus 1. So lambda max will always be hovering around the order of the matrix. Here you are seeing in the present example the lambda max is coming 7.59. Had it been perfect consistency in the decision makers, it should have been 7, because lambda max is always equal to the order of the matrix if the decision makers who have made their decisions are perfectly consistent. But since, as I told you, that the consistency is very difficult to maintain in taking so many decisions, so definitely some inconsistency crept in the calculations. So this 0.59, which is more than 7, is nothing but the inconsistency in the decision maker. So this way we could come up to a situation where a decision matrix can be analyzed, the priority vectors can be found out, and lambda max can be calculated. Here the time is not permitting. For this session I'll stop here, and in the next session when we'll come for the second part of this presentation, where we'll go for other calculation, we'll analyze the hierarchy which has been shown to you in this presentation, and we'll also synthesize the priorities in the next time. So please attend the next session also, so that will complete you the problem of infrastructure planning and particularly highway project selection. Thank you.